in listing and attribute notation, you also need to know one thing. Let's now define sets, definition of sets. Okay, what do I mean about definition of sets? We're looking at number one. We know that a set by definition is a collection of well-defined objects, isn't it? But now under these sets, there are also other sets that we can look into, like I'll give an example. Number one, subsets. Okay, what are subsets? I know back in secondary we learned that subsets are sets within a set, isn't it? When you come to varsity, it'll be the same, but it will carry a different definition to what that is, but in the same meaning and context. So here it is. Suppose that's a definition. Suppose A and B are sets. A and B are sets. Okay. Are sets. If that's a comma here, then if every element of A is an element of B, comma, then A is a subset of B. Okay, what I mean is that if every element of A is found in B, then A is a subset of B. What it means is, if this is our B, let me do this. If this is our B, then our A should be inside. So much that this definition will be true. Suppose that A and B are sets if every element of A, all the elements in A, is an element of B. In other words, what they mean is that A is found in B. That's what they mean. That's a subset. Okay. And then let's go to the second one. A second definition. Okay. Equal sets. By equal sets, what do we mean? So two sets. Okay, by the way, this is denoted by A is a subset of B. Okay, that's what it is denoted by. Then equal sets, two sets, say A and B are equal sets, are said to be equal. Alright, are said to be equal, i.e. A is equal to B if they contain the same elements. Okay, they contain the same elements. That is, i.e. A is a subset of B and B is a subset of A. Okay. So I know my handwriting is a bit rough here, but you should hear my words and listen to whatever I'm saying. So equal sets, two sets say A and B are said to be equal sets, i.e. A is equal to B if they contain the same elements. That is, A is a subset of B, meaning A is found in B, and B is a subset of A, meaning B is found in A. So they're found in each other. So if we have, this is set A, right? We have 1, 2, 3, Even set B needs to have 1, 2, 3. Okay, that's what it means. Those are equal sets. Okay, then we go to the third definition, the empty set. Okay, empty set. What's the definition of the empty set? Or sometimes called the null set. Okay, the definition of an empty set is, okay, this is a set having, okay, no elements. Okay, having no elements in it. It is denoted by, the symbol is this one here that you know from secondary, or when you come to varsity, it's this. It's a 0 here, then a slash there. Okay. And then you have to know that, note that an empty set is a subset of all the sets. In other words, it's found in every set. Okay. Now let's go to the other one, universal set. Okay, this is the totality of elements for any particular discussion or situation. This is a totality of so the universal set is a totality of the elements. Okay, the totality of the elements of any particular discussion or situation. So just looking at the totality, everything that is everything, if you have set A, set B, the totality, they add up. Okay, that's what, and it is denoted by, the symbol is capital letter E or capital letter U. Okay, that is the universal set. Okay, and then we go to the other one, complementary set. Okay, or let me say relative complement. What is relative complement? Okay, if A and B are sets, okay, comma, then the relative complement of a set A with respect to B okay, what we mean is the difference or the subtraction. The difference we're looking at the difference of A and B denoted by, the symbol is denoted or represented by A minus B. Okay, this is a relative complement. So A and B are sets. If A and B are sets, then the relative complement of set A with respect to B, meaning the difference of A minus B, okay, what does it mean? Is the set of all the elements which belong to A but do not belong to B. Okay, that is, i.e., A minus B is equal to, insert B notation, is equal to X, such that X is a member of A and X is not a member of B, or is a member of B complement. Or let me say it's not a member of B. Okay, that's what it means. E.g., what I mean is, if A is equal to 1, 2, 3, 4, 5, then B is equal to 2, 4, 6, 8. Okay, then A minus B, I'll answer two of them. Find A minus B, that's the first one. The second one is B minus A. Okay, so for A minus B answers, for A minus B, so we mean we're going to first write set A, 1, 2, 3, 4, 5, okay, minus set B, which is 2, 4, 6, and 8. Okay, so since we said A minus B means the numbers that are found that belong to A but do not belong to B. What are those numbers that belong to A and do not belong to B? What are those numbers? The numbers that belong to A and do not belong to B are 1 does not belong to, notice 1 belongs to A and does not belong to B. So the answer, this will be the numbers that belong, because A is positive. So A minus B means the numbers that are found in A and are not found in B. Which are those numbers? 1 is found in A, it's not found in B. What of 2? 2 is found in both, so it will not be an answer, we will cancel it. 3, is 3 found in there? No, it's found in only A. Okay, 3. What else? What of 4? We said the numbers that are found in A and are not found in B. 4 is found in both, so it will not be an answer. What of 5? Is 5 found in A and also in B? No, 5 is only found in A. Okay, so this is the answer. What of these? Well, these we said A minus B means the members that are found only in A and are not found in B. So we don't care about these. Okay, these are only found in B, they're not found in A. So we only care about those numbers which are found in A and are not found in B, which is 1 is found in A only. In other words, numbers that are found in A only. That's what it means. What of the second one, B minus A? What does B minus A mean? Since B is positive, what we mean is numbers that are found in B only. That's what it means. So let's write our 2, 4, 6, and 8. Okay, minus 1, 2, 3, and 4 and 5. So what are those numbers which are found only in B? Okay, is 2 found only in B? No, 2 is found in both, so we'll cancel it. What of 4? Is 4 found only in B? No, 4 is found in both. What of 6? Is 6 found only in B? Yes, that would be an answer. What of 8? Because 6 is not in A, right? What of 8? Is 8 only found, because B is the one which is positive, so we're saying numbers that are found in B, the positive one, only, and are not found in A, the negative one. Is 8 found in B only, are not found in A? Yes, 8 is an answer. What of these numbers which are left like 3 and we don't care about them. We're just looking at numbers which are found in B only and are not found in A. Okay, and those numbers are 6 and 8. That's what it means. Okay. So I hope these things make sense, guys. Okay. So sometimes they'll not use the word A minus B. A minus B, sometimes they'll use the word is the same as A slash B. And then B minus A is the same as B slash A. Okay, that's what they mean. Okay. Alright, let's go to part 2. Let's continue this in the second video.